for every transient stability and the transient disturbance. For that, if you consider that type of the disturbance, that can be a three-phase short circuit of a overhead line or the cable, and loss of generation and load rejection by use of any transfer. Other criteria is the generator dispatching. That means that our generation has that merit total. That means that every generator unit, any unit has a value. If you consider thermal generation, normally if it is IPP, directly it has some value for a one unit. And because of the hydro, normally the system control people are calculating the water value for that. According to that, they prepare the generating schedule for merit total. That means what is the cheapest unit? It may be a hydro, it may be a thermal. So we should prepare our transmission network for any of this generation schedule. That is what we are describing here. That means that our transmission network should be capable to face any of generation schedule. But in our system we have some problems in some area. We consider this criteria. That is that in southern area we operate ambiguity and some in maximum capacity. There are some overloadings in that area. So transmission system analysis. After preparing all the precise load forecast and generation plan, then we have to do the transmission studies according to that planning criteria. That is what we mean. So under the transmission system analysis, we do the load flow studies, reliability studies, that single contingent studies, short circuit calculation and stability studies. By doing these studies, we are identifying the places where our planning criteria is violated, and we are doing these transmission studies under 4 scenarios. That is hydro maximum 9 feet, thermal maximum 9 feet, hydro maximum day peak, and the thermal maximum day peak. So we are doing this transmission studies for every. If you consider the plan is 2008 to 2016, then we have to do these studies for each and every year. Apart from that, we are doing some studies for the lightly loaded condition. It is not, we are not doing for every year, but twice. Once in twice. So then that is the basic idea of the transmission planning, how we doing the transmission planning process. So before starting that transmission planning using power system simulation planning questions.
We have all the data for the PSSC network, so that can be translated for use on PSCAT using E-track. The data and transfer for using on PSCAT.
I'm not sure. Should be only our plan, transmission plan, so they are doing that specific importing the files. PSSE means Power System Simulation for Engineering.
So here this has two files. Do you have the two files? Or?
Yeah, the data is in one file and the diagram is the separate.
That's it. That's it.
That is called slider model, and data file is called save files. Save files. When we modeling the power system using PSSE, so we have several components in the power system, normally bus bars, branches, loads, machines, transformers, switch shunt. They are the basic transition equipment in our system. So the load flow study, normally we do that load flow study to determine the power system performance in steady state. So for that, as you know, here is that we have two methods, Newton-Raphson and the Gauss method. So Newton-Raphson in the PSSE we have three methods, and the Gauss series we have two methods. We can use them in different conditions. Normally that Newton-Raphson is using for the perfect conditions, that we have some voltage problem and difficult to solve, then we use that Gauss series. So this is the contingency analysis, that is to identify the network bottlenecks during the equipment failure or unavailability. So here we have the detailed description. For the normal condition, we are doing for power flow, and for the single contingency, we can study in steady state and also in the dynamic status. That means in the steady state, we just switch off one element and do the power flow and check whether there are some planning criteria violations. Normally, we have when we did a single contingency, we can see some voltage violations and the load violation but after that we can adjust the generation and everything, then we can solve it. So then we don't consider that it has a serious situation. Then the single contingency dynamic means that we can do the same thing in the dynamic status, then see whether there are planning criteria violations. And the double contingency is same, but we are not doing that. This is less probable contingency and the extreme contingency. We also have this steady state and dynamics that probability that is probable. It depends on the study. If we consider if we are studying the interconnection of the coal power plant, then the extreme case may be the Uttaram power plant unit dropping that Uttaram power plant, or three-phase short circuit of the Uttaram to Veyangoda line. According to the situation, that the extreme contingency can be weighed. So this is some extract from our maximum three-phase short circuit current. So you can see here that Anuradhapura, this is old Anuradhapura, that in 2015 it reached the switchgear capacity. So then beyond that 2015 we should be careful about that switchgear capacity, that short circuit level, because if we do more additions to that area, then it will exceed that 11